So here's some notes on the law of sines and law of cosines. So in the textbook, they give us the law of sines as being this formula. And now this will always work for all kinds of, all right triangles and non-right triangles. So, I mean, you can almost forget about sine, cosine, and SOHCAHTOA, but those are handy sometimes, so I'd like you not to forget about them. So one thing I'm going to modify here is, it's the same formula, but I think it'll make more sense if you think of this as being angle B, this is angle C, and this is angle A. Notice I'm using capital letters to represent the angles, and how the opposite sides are the same letter, just lowercase. That way you can see that the angles match up with the sides. So that kind of modifies our law of sines formula to sine of angle A over side A equals the sine of angle B over side B, and the sine of angle C over side C. And what we've got is just some proportions, and we can just compare two of them at a time, and that's how you do it. Now there's another set of formulas for non-right triangles called the law of cosines, and that's a little different. There's three different versions of the same formula, and I'll show you how those work here when we get to the examples. So when we're looking at this first example, and I want you to think a little bit, think back to what something Mrs. Gardner had you do way back when you were trying to solve triangles and have triangles be congruent. If you had all three sides, that locked you into one triangle. If you had, what am I saying? Thinking of. If you had angle, side, angle, that locked you into a triangle, and side, angle, side locked you into into the one congruent triangle. And if you have side, side angle, remember that there was more than one triangle possible, and that wasn't a congruence postulate. So we aren't going to show that triangles congruent, but what you did back then is related. And so what I'm seeing is I'm seeing a side with an angle in between, so the side's in between two angles, so that's like a angle, side, angle. So that's just to keep note of that, and that kind of helps you figure out that, well, I can use the law of sines for this problem because I can find that third angle, and that's one of the things I'm supposed to do in solving a triangle. So that is what? 120 plus 25 is 145, and then 180 minus 145 is 35 degrees, I believe. So now I can set up, what I see is I see an angle side pair. I've got this angle on that side that corresponds to it. So this is like angle A, and that's side A. Or you could call it angle B and side B. And it doesn't matter which angle it is, as long as you see that it's a corresponding angle side pair. So what I can do with this is I can write sine of 35 degrees over 6 is the same as sine of 120 degrees over B if you want, or C, doesn't matter, and then the sine of 25 degrees over C. And then what we can do to solve this is we can just ignore this last part and just concentrate on these two, and then we have a proportion, and I can cross multiply and divide. So 6 times the sine of 120, then I would hit equals, and then divide by sine 35. The other caution is, again, make sure that you're in degree mode, not radian mode. When I did this earlier, so as I said, when I did this earlier, I got 9.1. So that tells me that this hypotenuse is 9.1 long. Okay? So now what we can do is we can use the other, we got to find this other side, this side C, and so what we can do is we can ignore this middle proportion right here, pretend it's not even there, and just say 6 times the sine of 25 divided by the sine of 35. So 6 sine 25, hit equals, divide that by sine 35, and when I did that earlier, I got 4.4. So this side is 4.4 long. So we solved that triangle. We found the angle, and we found the two missing sides. And this is using law of sines, because we have that angle side pair. So the problem with this one now is I'm seeing a side angle side pattern. And if I try to do the law of sines, well, I can say sine of 60 degrees because that's the only angle I know. And the trouble with that, I don't know the side opposite. And I don't know any of these other two angles. And right now, I don't have any way of finding those. So what we do, we need another tool. And that other tool is the law of cosines. So if you go back and take a look at that formula, you'll see that. What you want to pay attention to, and one reason why I pointed out the side angle side pattern is it'll always happen when you have to use law of cosines that you'll have the angle in between the two sides. And it doesn't really, if you look at those three formulas, they're all the same, and all that tells me is that I'm looking for this opposite side. So whether it's C or A or whatever letter you want to call it, it's going to be that opposite side. So I'm just going to write C squared equals A. Now it doesn't matter which is A or B, but I'm just filling out that formula. So A squared plus B squared minus 2 times A times B times the cosine of the angle, which is 60 degrees. And now what's great about the graphing calculators, and you can just key this in right the way it is. Just do it as it comes. I did this earlier. I got 624. Then to get C, I'm going to take the square root of both sides, and that left me C was about 25 if I do some rounding. So now I've got the three sides. Now I just got to find the other angles. And now that I've got an angle side pair, I can go back and use law of sines, which is a lot easier. And usually with doing these is the most you'll ever have to use the law of cosines for is once. And then you can go back and use another technique. So now I'm going to show you how to find one of these missing angles. So now I've got this angle side pair, and the law of sines says you take the sine of the angle, put that over the opposite side, equals the sine of, I don't know, let's call this angle B. Let's call sine of angle B over 20, and it is a proportion. We can just cross multiply and divide. So 20 times the sine of 60 divided by 25. I did that on my calculator. I got that the sine, now remember it's the sine of angle B, that's equal sign. Let me erase it and write it right. So the sine of angle B equals 0.6928 and a bunch of other decimal places that we don't want to write down. So what you got to think back now is, hey, if I know the sine of this angle is this, how do you undo that? And when I did this in class, people noticed, oh, why don't I just do second sine? And that's the arc sine. That tells me, that undoes taking the sine of the angle. And what happens in your calculator, you'll see sine to the -1. Not the reciprocal, it's a different function. And then you can do that angle, that decimal. And when you do that, I came up that it was about 44 degrees. So that tells me this is 44 degrees. And then I could do law of sines again to find this other missing angle, or I can just do this easy way and know that this triangle has the sum of the angles, interior angles is the sum of 180, and just add those two, you get 104. 180 minus 104 is 76 degrees. So now we get a couple of word problems. They're nice. They give us the picture. So what I'm seeing with this one is I've got an angle in between two sides. So that's a side angle side pattern. I'm looking for the side opposite this angle. So that's a law of cosines. So I'm just going to write C squared equals 800 squared plus 900 squared minus 2 times 800 times 900 times the cosine of the angle, which is 70 degrees. Notice, this is one thing I noticed. That number goes here, that number goes there, the angle goes there. Now when you crunch this on your calculator, I got, what did I get here? Let's see. I came up with about 95742.25, and then you take the square root of that. I came up with about 978.5 feet across that pond. Okay. So what I'm seeing for this one is I know two angles, so I can find the third angle, which would be 180 minus 130, which is 50 degrees. And I know that this is 500. And I'm looking to find the distance from station A. So I'm looking for this distance here. So I can use I got an angle side pair, right? I know an angle with a side opposite, so that's a law sine problem. Nice and easy. So sine 50 over 500. And since I only want the side opposite the 60-degree angle, I'm just going to write sine 60 over x. Find the cross products. So 500 times the sine of 60 divided by the sine of 50. And when I did this earlier, I got, what did I get? 565, I guess. 0.3. So I hope that helps. I'll put the answers all online and, oh, wait a minute. There's one other thing I got to show you. Here, wait a minute. So this is number 9 on page 54, and I took a picture of the problem with the answers. Now, we don't, on your page 54, you don't have one of those red answers. So how do we find it? Well, I usually need an angle to do these kind of things. They didn't give me one, but I do know the three sides. So I could do this. I could start to set up the law of cosines. I can say 9 squared equals 20 squared plus 25 squared minus 2 times 20 times 25 times the cosine of angle C, which I don't know. So I could just work backwards. On my calculator, I can say 9 squared, and then I'm going to subtract 20 squared minus from both sides. I'm going to subtract 25 squared from both sides. Then that is equal, what's left is that's equal to this mess here. So I'm just going to divide both sides by this part of that expression. So negative 2 times 20 times 25. And that's what the cosine of angle C looks like. Now, we can crunch this on a calculator. That came out a little dark. Now, the problem that people were having in class is they forgot when they did the division, they didn't remember to include that in parentheses, because you could divide that whole expression on top by the denominator. They were just dividing by negative 2 times 20 times 25, so don't do that. So then, since we know what the cosine of angle C is, we're going to do second cosine, do the arc cosine to get that answer. So let's see here. So we're going to do arc cosine, second cosine of that 0.944, and that's where they got the 19.3 degrees from. Okay, so now, since we've got an angle and we've got a side, we can do a law of sines problem, and I'll try to squeeze that in up there to shorten up this video. So I can say sine of 19.3 over 9 equals the sine of, I don't know, let's do angle A, over 20. Cross multiply, divide, do second sine, you're going to get the 47.2, and then add those two angles together, subtract it from 180, you'll get that obtuse angle. Okay, so I hope that helps you complete this work. I'll have these answers online too.